I'm about to. What's up?
Have you tried those breakout groups yet?
What?
Have you tried doing the breakout groups?
What's the name? Started talking about that K-Core.
Dude, they're legit.
What do you gotta do?
So you just hit the breakout group. It randomizes. It breaks them up into even groups.
Right.
So say that you wanted to like
let them work on a problem.
Or you guys are working on a problem, then you chimed in to kind of see if they understood it or whatever. Right. They can work and you can. Like Fee and I did it with the prologue for Canterbury Tales.
Now, can you save the things? Because like we're gonna give kids working on word problems in trig next week.
Can you save their groups?
Like for the next day or whatever.
There's got to be a way. I gotta see if you can maybe like if they can join just their group. There's got to be a way. You can time it. There's a timer that times whatever they're doing, and then it puts them back into the main thing. It's pretty cool. It speeds up the whole thing. You know what I mean? Rather than kind of just be on.
Right.
So I gotta figure that out though. That's good.
All right. Let me know. All right, so today we're going to start section 6.1, polygon angle sum theorem. All right, our objectives: to find the sum of the measures of the interior angles of a polygon. Find the sum of the measures of the exterior angles of a polygon. All right. So basically, when we're looking at a polygon, all right, whatever it is, that's the interior regular angle, and then the exterior is the one that forms the linear parallel. All right, now there are special properties that we will discuss with these. All right, and we'll start with the interiors. We'll start with a triangle, which is right here. We know the angles add up to 180 degrees. All right, so now we want to generalize it to go to all polygons. So we add a side, so now we have a four-sided figure known as a quadrilateral, and we draw on a diagonal. Diagonal is a line segment that goes from one vertex to another that isn't already a side. All right, so basically, okay, what that diagonal does is it divides it up into two different triangles, non-overlapping. That's important. We're not going to draw all the diagonals in. We're just going to draw them from one vertex. All right, so if this part of it adds up to 180 and that part of it adds up to 180, that tells us a quadrilateral always adds up to 360. Okay? And if we want to generalize it more, we move down to a pentagon. All right? And again, we can draw in all the diagonals from one vertex. All right? All right, if I look at the hexagon, same thing. All right? I draw all the diagonals in from one vertex. And what you see when you do that is you always end up with non-overlapping triangles. All right. So basically, this has 3 triangles, so 3 times the 180 would be 540. The angles of a pentagon always add up to 540. Hexagon has 4, so 4 times 180 would be 720. So the angles always add up to that of a hexagon. Well, we want to generalize it. So we're just going to put that data together. When we had 3 sides, we had 1 triangle. So we did 1 times 180, made it 180. When we had 4 sides, we had 2 triangles. 2 times 180 would be the 360. 3, when we had 5 sides, and 3 times 180 is 540. All right, 4 times 180 is 720. Now, what number did we always multiply by? 180. What is the relationship between the number we multiply 180 by and the number of sides? Always 2 less. That is because the number of triangles is always 2 less than the number of sides. It's always 2 less than the number of sides. All right. Putting it all together, we have theorem 6.1. The sum of the measures of the interior angles of an n-gon is 180 times n minus 2, where n is the number of sides. Where n is the number of sides. All right. So you'll come across several problems, and that's what we're going to spend going through today. All right. Find the sum of the angles of a polygon given the number of sides. All you need to do is plug in the number of sides for n. All right. Just plug in the number of sides for n. So what is the sum of the angle measures of a heptagon? Well, a heptagon has 7 sides. And all you would do is 7 minus 2 times 180. 7 minus 2 is 5. 5 times 180 is 900 degrees. All right. So right now might be a good time to brush up on your polygon names up to and including 12. 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 3 is a triangle. 4 is a quadrilateral. 5 is a pentagon. 6 is a hexagon. 7 is either a hepta or a septagon. 8 is an octagon. 9 is a nonagon. 10 is a decagon. 11 is an undecagon. And 12 is a dodecagon. All right. After that, you can simply write the number of sides dash con. So for example, if the figure had 22 sides, for this class, we're going to call it a 22-gon. And then go from there. All right, so if they want the angle sum, you simply take the number of sides, subtract 2, and multiply by 180. All right. Now, sometimes they will ask to find the missing angle measure or measures given the number of sides and other angle measures. All right, first off, we'll use the number of sides, figure out the angle sum. All right. Subtract the total of the angles given from this sum, and then problem solve accordingly. All right. So for example, if you're given an octagon where 6 of the angles measure 145, what do the remaining 2 congruent angles measure? So an octagon has 8 sides. I'm going to do 8 minus 2 times 180. 8 minus 2 is 6. 6 times 180 is 1,080. Means the angles of an octagon add up to 1,080. Well, they tell us 6 of the angles measure 145. So 6 of the angles measure 145. I can figure out their total by doing 6 times 145. That gives me 860. We then subtract. I'm going to do 1,080 minus 860. I get 220. All right. Now, this is where the problem solving comes in. What do the remaining 2 congruent angles measure? If the angles are congruent, that means they're the same. They have the same measure. So we can take their sum, which is 220, and divide by the number of angles, which is 2. So each of those angles measures 110 degrees. I'm going to stop presenting for 1 second. I got to do something. Give me 1 second. Okay, so working backwards, given the angle sum, find the total number of sides. Given the angle sum, find the total number of sides. So we're going to go in the exact opposite order. So we're going to divide by 180 instead of multiplying. And then instead of subtracting by 2, okay, instead of subtracting by 2, we're going to add 2. All right. So if they tell you the angles of a triangle add up to 1,800, all right, if they tell you the angles of a triangle add up to 1,800, you simply divide by 180 to get 10. You then add 2 to get 12. So that polygon has 12 sides. Better known as a dodecagon. All right, now we have special polygons. What if all the angles are the same? Equiangular, EQUIAGNGULAR, equiangular polygons have angle measures that are all the same, as do what we call regular polygons. Which are both equilateral and equiangular. All right, so if they tell you it's a regular polygon, all the angles are the All right, once we know the sum, we simply divide by the number of sides or angles. They're always the same. All right, now for those of you that want a formula for that, 180 times n minus 2 divided by n. 180 times n minus 2 comes from theorem 6.1. We then divide by n. All right, we're going to show you how to problem solve with this, and if you choose to use that formula, certainly feel free to. However, we're going to give you an alternative way to look at that. All right, so if we're going to use that formula, where's the angle measure of a regular nonagon? A regular nonagon has 9 sides. So we're going to do 180 times 9 minus 2 divided by 9. That's all it is. We end up with 140 degrees. All right, so when it wants an angle measure of a regular or an equal angular polygon, we can use a formula if we want 180 times n minus 2 divided by n. All right. Any questions thus far about what we've gone over? Okay, so let's move outside. Just kidding. We're actually going to discuss angles outside the polygons, which we learned are called exterior angles. Okay? Now, here's what happens with exterior angles. Let's say we have an equal angular triangle. Each one of these is 60 degrees. The exterior angle, recall, forms a linear pair, so it's 120. All right, there would be 3 of them, so 3 times 120 equals 360. So the exterior angles of a triangle add up to 360. Let's move to a square. All right. A square is a regular quadrilateral, so each of the interior angles are 90 degrees. It means each of the exterior angles are also 90 degrees. Well, there's 4 of them. 90 times 4 is also 360. All right. Finally, if we look at a pentagon, all right, pentagon has 5 sides, so 180, all right, times n minus 2, which would be 3, divided by 5. All right, 180 times 3 is 540. 540 divided by 5 is 108. All right, if the interior one is 108, to get the exterior one, we subtract from 180 and we get 72. Well, if we take 72 and multiply it by 5, guess what we still get? 360. And hopefully you notice that no matter how many sides there are, the exterior angles always add up to 360. Giving us theorem 6.2, the sum of the measures of the exterior angles in a polygon, one at each vertex, is 360 degrees, no matter what. All right, if one or more is missing, add up the ones given, and much like interiors, subtract and use relationships to find missing angle measures. All right, so that part of the process is going to be just like the interiors. You look really nicely dressed today. I got instructional counseling. Oh, yeah? Yeah, I can't show up in sweats to instructional counseling. Gotta make it seem professional.
Come on, man. I'm
Come on, man.
That's like Homer Simpson said before he went great. To professionalism.
And,
Oh, sorry.
I got rice stuck in my throat. I can't get it out.
Why don't you drink something?
So I keep trying. It won't get out.
Yeah,
All right.
Yeah, throw up. That's what you gotta do.
Got to get it out.
Throw up.
Give me a little Heimlich. Calm it out. All right. Now we return to equal angular and regular polygons, all of which can be summarized in the following. The exterior measure of any equal angular or regular polygon can be found using the concept or formula 360 divided by n, where n is the number of sides. Furthermore, if you choose the interior angle measure of a regular equal angle or equal angular polygon can be found using the alternative formula 180 minus 360 divided by n. All right. Okay, I'm going to go get a drink of water really quick. What I want you guys to work on is just the first two. So 1A and B and 2A and B. Work on that really quick, please, while I get a drink. All right, so find the sum of the angles of the following polygons. Make sure we follow directions. All right, so 1, 2, 3, 4, 5, and 6. There's 6 sides. So we're going to do 180 times n minus 2. Then is 6, then it's 4. 180 times 4 is 720. A 15 gone, we're just going to minus 2. 15 minus 2 is 13. We're going to multiply that by 180. And we end up with 2,340 degrees. So when they ask you to find the angle sum, that's all you're doing. That is different than in number 2, where find the measure of one angle in each of the regular polygons. Now, I'm going to walk through how you do it with exterior angles rather than interiors. We did it with the interiors. I'm going to show you how to do it with exteriors because I think it's a more straightforward method, and then you can just pick which one you want to do. All right? An interior and an exterior always form a linear pair. The difference is we know what these add up to. All right? So to get an exterior angle, I take what they add up to, which is 360, divide that by the number of sides, which is 40. The net result of that is 9. That means the exterior angle equals 9 degrees. To then get the interior, or the measure of a single angle, all we're going to do is use linear pairs, 180 minus 9, and we get 171 degrees. All right, that's why I use exteriors a lot, especially later on when we start working backwards. It's going to be a lot easier. All right, now you need to be able to work with fractions. So we got a 33 gone. All right, so again, I go back to, there's my interior, there's my exterior. My exterior is 360 divided by 33. Okay? If you go to a calculator and you do 360 divided by 33, gives you a repeating decimal, 10.90 with the 90 repeating. You are going to be asked to find the exact answer and represent it as a fraction. Telling you that now. All right, so here's what you do. Number one is you subtract the non-decimal part. So you minus the 10. All right, and I know this is going to be 10. All right, and then all I do is convert it. So math and 1. And we get 10/11. All right, so that means the exterior angle measure is 10 and 10/11. So that means in turn to get the interior angle measure, I'm just going to subtract 10 and 10/11 from 180. And that's going to give me 169 and 111. All right, so 169 and 111. All right, so you need to be able to manipulate fractions when doing these problems. All right. All right, so number 3A, solve for the variables in the following diagram. All right, now they give us these as congruent. So if that one is 9x minus 1, this was also 9x minus 1. They also tell us these lines are parallel. Means same side interiors are supplementary. So if that one is 90, this one is also 90. All right, so the angles we have thus far, 90 and 90 is 180. Plus 10 and 9 is 19. 19 and 9 is 28. 28 plus 5 is 33x. 3 minus 1 is 2. 2 minus 1 is 1. 1 plus 11 is 12. All right, so that's what all those angles add up to. And I set that equal to the sum. 1, 2, 3, 4, 5, 6 sides. 6 minus 2 is 4. 4 times 180 is 720. That means those angles add up to 720. All right. $33x plus 192 equals 720. I'm going to minus 192, divide by 33. That'll get rid of both. Divide that by 33. And I get x equals 16. I then plug that back in. 16 times 10 is 160. 160 plus 3 is 163. 9 times 16 is 144. 144 minus 1, 143. This one's also going to be 143. 5 times 16 is 80. 80 plus 11 is 91. So those are my angle measures. Part B says are sides AF and DE parallel. Well, if these are parallel, all right? If these were parallel, okay, these angles would be same side interiors. They'd be supplementary. That's 90 and that's 91. So therefore, no, same side interior do not add up to 180. All right. All right, last one, number 4, that we'll do today. We'll finish these up tomorrow. Each of 4 exterior angles of a hexagon measures 80 degrees. If the remaining exterior angles are congruent, what does each one measure? All right, 4 of them each measure 80. So 4 times 80 is 320. Remember, exterior ones are constant. They always add up to 360. 360 minus 320 is 40. It says the remaining exterior angles are congruent. There's 2 of them. So 40 divided by 2 makes it 20 degrees. All right. So the homework for this section is posted in Google Classroom. Is due not tonight, but tomorrow at midnight. All right. For 1 through, 24, there's really no work you need to show. It does say to round to the nearest tenth. If you want to do that in the assignment, that's fine. But please realize for the quiz, you are going to have to write it as a fraction. For 25 through 29, all right, for 25 through 29, algebraic, I need to see your equations. So 25 through 29, I need to see your work. All right, 30 through 35, it goes back to just being angle sums, so nothing really you need to do with that. 36 to 44, there's really no work to be shown. And then the remaining ones we'll continue working with tomorrow. So that is due not tonight, but tomorrow night at midnight. But if you want to get started, feel free. All right. I will be here for another 3 minutes, and then I'll be probably here after school. If you're good to go, you are good to go. And I will see you tomorrow when we talk about how school's going to go once we come back from hybrid. Be safe, guys.
Have a good day.
Be good.
Have a good day.
Thank you.
Bye.
Bye.